Then what we did is whenever we are having an amplifier circuit, if there was an effect of a stray capacitance, what we did is we considered an amplifier having a common impedance that was taken as Z, and this portion was replaced using two impedance taken as Zi and Z0 respectively. Similarly, what we are trying to do is we replace this effect of C B prime C using the capacitance that is available at the input side, which was taken as C B prime E, that is the capacitance that is present between a virtual base and an emitter. And at the output side, what we did is we taken a capacitance named as CCE, which is the capacitance that is available at the collector and the emitter terminal. So after constructing this equivalent circuit, then what we did is we taken some analysis of a single tune amplifier. If we consider the analysis of a single tune amplifier, how the analysis was done is, if we consider the circuit portion, wherever the circuit comprises of more number of resistances, all the resistances were taken as an equivalent resistance denoted as RT. Similarly, the capacitance that were available at the output portion was taken using a single notation named as C0, and the inductance that was available at an output side was taken as LP. Then we further carried out the analysis, and the final equivalent circuit that was obtained in the previous class was an input signal taken as Vin was connected to a resistance taken as RBP prime, that is further connected to a resistance named as RB prime E, that is further connected to a Miller capacitance taken as Cm, and the output portion was connected to a current source taken as Gm into Vb prime E, whose output was connected to a capacitor taken as C0, and the inductive component was taken as LP, and the resistive component was taken as RT. Then we taken the output voltage as V0 for this case. This figure represents the simplified equivalent circuit of a tuned amplifier. Then what we did is we are having a term named as Vb prime E. We computed Vb prime E using voltage division rule. That is, Vb prime E is available at the input side of the circuit. If I am going to apply voltage division rule, how the value of Vb prime E will be computed is the same resistance that is taken as Rb prime E divided by sum of the resistance that is taken as Rbb prime plus Rb prime E multiplied with the voltage that is Vin. The reason why Vb prime E needs to be computed is for computing the input voltage Vin. That is, from this equation, Vn can also be written as Rbb prime plus Rb prime E divided by Rb prime E into Vbe. So this will be the input voltage of a tuned amplifier. Then our objective was to compute the gain. For computing the gain, we need to find what is the output voltage, that is V0. So in by Ohm's law, we all know that V is equal to I into R. Now what we are trying to do, we are trying to compute what is the output voltage, that is V0. So how to compute V0? If you refer to the circuit that is available in this portion, V0 is being available as an output. If I want to express V0 as a product of a current into resistance, the current portion that is available in my circuit is Gm into Vb prime E. That is, V0 can be expressed as Gm into Vb prime E in place of the current. Now the question rises, what will be the value of R, or how to express V in the form of IR? The simple notation is, since we are having three passive elements at the output side, instead of taking it as an R, I am going to represent the resultant value of V0 as equal to Gm into Vb prime E into Z, where Z represents the impedance. We all know that an impedance might be a series combination of resistance, inductance and a capacitance. So I am representing the value of V0 as equal to Gm Vb prime E into Z. But so far I have not computed what is the value of Z. I simply mention it that it will be the combination of all three portions. The reason is we are having three passive elements at an output side. In order to compute Z, what I am going to do is I am going to find what is the admittance value of the output side. That is, I am having capacitance, an inductance and a resistance. So I am trying to find what is admittance, and from admittance I am going to find what is the impedance. So the relation between admittance and impedance is Y is equal to 1 by Z. From this, if I need Z, Z will be equal to 1 by Y. So I am going to first initially find what is the value of admittance that is going to be obtained, and from this value I am going to find the impedance value. Once finding the impedance value, I will be in a position to find what is the resultant output voltage V0 of a single tune amplifier.